All right, welcome back, everyone. Today I'm going to be talking about solving quadratic equations using the quadratic formula. So, just to recap what we already know that the quadratic formula and factoring are two different ways to solve quadratic equations. Now, why do we need two different ways to solve quadratic equations? Well, because factoring doesn't always work. There are some cases where a quadratic is impossible to factor because our discriminant is less than zero, and we'll get to that in one of our next topics soon. And sometimes it's impossible to factor because perhaps the zeros are not whole numbers, right? And so it's going to be, some strange root or some number that isn't a whole number that we wouldn't really be able to know about just by trying to factor something. So sometimes factoring is either extremely difficult, other times it's completely impossible and there's just no factored form that exists. And so factoring is not the end all be all when it comes to solving quadratic functions. However, the quadratic formula it is, okay? And the quadratic formula is a much superior method to factoring because it works every time. Now, sure, maybe it takes a little bit longer to do than factoring when you are able to factor easily and in those few cases where you can easily see what to factor and what to not factor. However, this method it works every time, and so this method is far superior when it comes to solving quadratic functions. Now, factoring has its usefulness too for various other things. I don't think factoring is a bad skill to have, but if the goal is to solve quadratics, then the quadratic formula is much better because it works every time versus a different method that only works in a few very specific cases and not all the time. So let's talk about the quadratic formula. The quadratic formula is used to solve problems in standard form when y, or we should really say 0 here, 0 is equal to ax squared plus bx plus c, where the chart ax squared and c cannot be completed or is difficult to complete. Right? When we're not able to figure out what are two numbers that multiply out to b and that add up to b and that multiply out to a times c. So the quadratic formula looks like this. It's that x is equal to negative b plus or minus the square root of b squared minus 4ac, and all of that over 2a. And keep in mind, this a, b, and c here, these are the same a, b, and c as the a, b, and c in the quadratic formula. So basically, if we know that we have a quadratic equation that says 0 equals ax squared plus bx plus c, we can solve it from there, assuming that A, B, and C are filled in, that we know what those numbers are. So let's start with an example here. It says the flight of an air balloon is given by the equation h is equal to negative 2x squared plus 7x, where x is the time in hours and h is the height in meters. When is the hot air balloon at a height of 2 meters? Okay, so first of all, we need to switch height for 2 meters. So our first step would be to say that 2 is equal to negative 2x squared plus 7x. Now our next step is we need to get it into this form, the form of 0 equals ax squared plus bx plus c. Because what a lot of people might do here is they might say, oh, so look, negative 2 is a and 7 is b, and they'll forget about this 2, the fact that we need a 0 on our left-hand side in order for this to work. So we're going to subtract 2 from both sides of our equation to get 0 equals negative 2x squared plus 7x minus 2. And now we're at the spot where we can use the quadratic formula to solve this. So a is equal to negative 2, right? Negative 2. b is equal to 7, right? We have 7. And c, I'll grab a different color here actually. C is equal to negative 2, right? Because of this negative 2 here, right? So the a, b, and c from the original equation of 0 equals ax squared plus bx plus c, it lines up with the a, b, and c I'm going to use and then plug into my quadratic equation. So my quadratic formula is x equals negative b plus or minus square root of b squared minus 4ac all over 2a. Oops. Like that. And now let's plug it in. So a is negative 2. b is 7, 4, -2, and they're both -2, okay, over 2 times a, which is -2. Okay, so my next step, I would like to figure out what numbers in our square root sign, so I'm going to ignore almost everything else and just find out what numbers in there. So we have 7 squared, which is 49, and then 49, let's see here, 49 minus 16, yes, 49 minus 16, so 33. And if you are asked to give an exact answer, this is good enough. In this case, I am going to do an approximate answer, especially since it is a word problem and we don't really know what height this necessarily is, and also because not both answers are necessarily applicable given the context. However, there are times when just leaving it at this answer right here could be enough. Now, in this case, we got a positive under our square root sign, so there are two solutions. So technically, there would have been a way to factor this, but it would have been with a decimal, right? It would have been something to do with root 33, right? Now, if the answer you get in your b squared minus 4ac actually does turn out to be a perfect square, then perhaps you could have factored, but either way, it's too late now, and the quadratic formula will still work for you in those cases. But anyway, let's move on. So root 33 is approximately what? Root 33 is approximately 5.74, let's say. Okay, so then let's see what are our two answers. So let's do first plus 5.774 minus 7, and then divide by -4. We end up with 0.31 approximately. Or what about our other answer? So what if we do -7 minus 5.74 divided by -4? We end up with 3.185. All right, very good. So therefore, we actually do have two answers that make sense. It means that there's two different times when the hot air balloon or the air balloon is at a height of 2 meters. Both of these make sense. Sometimes you may get one of the answers as a negative answer, and that may not make sense depending on the context. But it's not about whether or not what's in our square root brackets ends up being positive or negative, right? It's not about that per se. It's about which is our answer, positive or negative, and whatever our answer is, does it make sense with the context of our question? Okay, so with that said, I'm going to write a conclusion statement that says, therefore, the balloon has a height of 2 meters at 0.31 seconds and 3.185 seconds. Okay. All right, so there we go. Let's try one more example 2. Okay, example 2 says, a bird swoops down towards the ground to eat a bug. The height m of the bird is given by the equation h is equal to 0.6x squared minus 6x plus 19, where x is the time in seconds. When is the bird at a height of 2.5 meters? Okay, so similar deal here. First, we're going to plug in 2.5 meters to h. So 2.5 meters is equal to 0.6x squared minus 6x plus 19. Now again, to use our quadratic formula, we must push everything to one side. We must have 0 on the left and all of our coefficients and constants and variables and everything else on the right. So let's do that. Let's subtract 2.5 and we'll get 0.6x squared minus 6x plus, I believe, 16.5 we'll still have left here. Yep, that looks good to me. Okay, and now let's plug this into our quadratic formula, which again is x equals to -b plus or minus the square root of b squared minus 4ac all over 2a, where a is 0.6, b is -6, and c is 16.5. Okay, so x is equal to negative b, right? So this is going to be negative 6, which will end up being plus 6, plus or minus b squared, which is negative 6 squared, minus 4, 0.6, 16.5 over 2a. So 2 times 0.6. So we end up with 6 plus or minus, and then something over 1.2. And let's see what this would be. So this part would be 36, right? Negative 6 squared would be positive 36. And then minus 4 times 0.6 times 16.5, which is negative 39.6. So then the next step would be to find out what's in our square root sign. And it's going to be negative 3.6. Now, can we have a negative in our square root sign? No, not in the real number system. So at this point, we can actually stop here and there's no need to go forward, regardless if it's a word problem, regardless what type of problem this is. You can stop here. You can say there are no real solutions to this. Or in the context here, I'm going to write no real solutions, but I'm also going to write a conclusion statement that sums up the no real solutionsness of this. So here it asks, what we are trying to calculate what times for x is the bird at a height of 2.5 meters. Because there's no real solutions, what that means to us in the context of this bird is that there are no possible times when the bird is at 2.5 meters. Or in other words, the bird never reaches a height of 2.5 meters. So I'm going to write that. I'm going to say, therefore, the bird never reaches a height of 2.5 meters, right? This never happens because if it did, we would be able to find a solution here, right? So keep in mind for all quadratics, whenever we're solving, and regardless how we're solving, there's always either 0 solution or 1 solution or 2. In this case, there's no solution, so this one's 0. The last example, we had 2 solutions, and both of them ended up being applicable. Sometimes there's only 1 solution, right? If what's in our square root ends up being 0, then there's only 1 solution. Now we'll talk more about that in the next topic, which has to do with the discriminant and how all of that works. But for now, I do have some homework, suggested homework questions for the Nelson textbook, which is linked in the description for anyone who is interested in doing some homework. So the quadratic formula and the discriminant is these pages. So after this video and then also the next one, also lesson 5 as well, to try these different questions. They have questions all about the quadratic formula and the discriminant to get you practicing. The quadratic formula, it can seem really intimidating at first, and it can feel like, oh, I'm never going to remember this formula. But the thing is, reality is that after you've used it enough times, you will remember this formula. It is the reality, okay? So I wish everyone the best of luck, and I will see you next time. Bye, everyone.